May 27, 1942. Prague, Czechoslovakia. The spring morning air hung heavy over Krčmajerova Street. Josef Gabčík crouched behind a tram stop, his fingers wrapped around cold stamped steel. The weapon in his hands looked more like plumbing parts than a military firearm. 30 yards away, an open-top Mercedes rounded the corner. Inside sat Reinhard Heydrich, the butcher of Prague, architect of the final solution. Gabčík stepped into the street, raised his Sten Gun, and squeezed the trigger. Nothing. The bolt locked. The cheap magazine had jammed. In that frozen moment, a $10 British submachine gun failed to fire, and history held its breath. This was the Sten Gun. British officers called it the plumber's nightmare. The stench gun, a roughly machined collection of scrap metal that soldiers claimed was exciting to be around because it tended to go off when knocked. Yet this crude weapon, rejected initially by the very military establishment it would serve, became one of the most produced firearms of World War II. Over 4 million were built. It armed resistance fighters from Norway to Greece. It became the symbol of underground warfare across occupied Europe. And it began with disaster. June 5, 1940. The beaches of Dunkirk fell silent as the last British destroyer disappeared across the English Channel. Behind them lay the smoking wreckage of an army. Over 10 frantic days, the Royal Navy and a flotilla of civilian vessels had evacuated more than 330,000 soldiers from France. The men were saved. The equipment was not. German soldiers now walked among the debris of British defeat. Nearly 2,500 artillery pieces lay abandoned in the sand. 85,000 vehicles, including 445 tanks. 75,000 tons of ammunition. 416,000 tons of supplies. 11,000 machine guns. Tens of thousands of rifles, pistols, and submachine guns. All left behind. Britain had saved its army, but lost its arsenal. In London, the mathematics were terrifying. The Home Guard numbered 1.5 million men. Many drilled with broomsticks. The threat of German invasion was not theoretical. It was expected. German forces had conquered Poland in 5 weeks. Denmark fell in hours. Norway in 2 months. France, Belgium, the Netherlands, and Luxembourg collapsed in 6 weeks. Britain stood alone. And Britain was unarmed. The military establishment knew what was coming. German infantry carried MP-38 and MP-40 submachine guns. These weapons delivered blistering firepower at 500 rounds per minute. British soldiers carried bolt-action Lee-Enfield rifles. Fine weapons. Accurate. Reliable. But in close combat, a rifle that fired 15 rounds per minute could not match a submachine gun that fired 500. The British military scrambled to acquire Thompson submachine guns from America. The Thompson was beautiful. Polished wood. High-grade steel. Exceptional craftsmanship. It was also exceptionally expensive. Each Thompson cost $200 to produce. In today's money, that translates to roughly $2,300 per weapon. Britain bought every Thompson it could find. It was not enough. When America entered the war in 1941, demand vastly outpaced supply. Britain needed weapons. Cheap weapons. Weapons that could be produced in massive numbers. Weapons that could be manufactured in small workshops rather than dedicated factories. The country was running out of cash and running out of time. Late 1940. The Royal Small Arms Factory at Enfield received an urgent directive. Design a submachine gun that could be mass-produced using minimal machining. Keep costs below £3 per unit. Maximize simplicity. Prioritize speed of manufacture over refinement. Major Reginald Vernon Shepard and Harold John Turpin began work immediately. Shepard was a veteran ordnance inspector, recalled to service after retirement. Turpin was a senior draftsman at the Royal Small Arms Factory. Neither was a traditional gun designer in the romantic sense. They were practical engineers tasked with solving an impossible problem under impossible constraints. They examined captured German MP-40 submachine guns. The MP-40 used a simple blowback operation. Fire from an open bolt. Fixed firing pin. The magazine mounted on the side rather than below the weapon. Turpin and Shepard stripped the concept to its absolute minimum. They eliminated everything that was not essential. The result was radical. The weapon they designed used just 47 parts. Only 2 required machining. The barrel and the bolt. Everything else could be stamped from sheet metal and welded together. The magazine housing could rotate 90 degrees to cover the ejection port when not in use. The barrel was detachable. The stock was a simple metal tube. No wood, no polish, no aesthetic consideration whatsoever. December 1940 through January 1941. Harold Turpin handmade the first prototype at the Philco Radio Works at Perivale in Middlesex. 36 days of work produced the first Sten Gun. It was designated T40/1. T for Turpin, 40 for the year, 1 for the first prototype. This weapon now resides in the historical collection of the British Army's Infantry and Small Arms School Corps at Warminster. It is a document of desperation transformed into innovation. The weapon was tested at Enfield on January 10, 1941, and at Hythe on January 21. The results shocked the military establishment. The gun worked. Not elegantly, not beautifully, but it worked. It fired 9mm parabellum ammunition at a rate of 550 rounds per minute, the same cartridge used by German forces. This meant resistance fighters could acquire ammunition from captured German supplies. The effective range was approximately 100 yards, far less than the Lee Enfield rifle's 500 yards. But for close-quarters combat in buildings, villages, and urban environments, that was sufficient. The Army approved the weapon with remarkable speed. The name Sten was an acronym. S for Shepherd, T for Turpin, Yen for either Enfield or England, depending on the account. The designation reflected the weapon's origins in practical engineering rather than romantic military tradition. This was not a weapon with heritage. It was a weapon born of crisis. The first production model was the Mark I. It featured a conical flash hider, wooden handguard, and vertical folding forward grip. These features were quickly deemed unnecessary luxuries. In August 1941, the simplified Mark II was demonstrated at Pendine. The flash eliminator was gone. The handguard was gone. The removable barrel now projected 3 inches beyond the barrel sleeve. The result looked like something assembled in a plumber's workshop. That was the point. The Mark II could be produced in 5 man-hours. Cost per unit was £2, 87 pence. About $10 at the time. In modern currency, roughly $130 per weapon. Compare this to the Thompson at $2,300. The industrial implications were profound. Traditional gun manufacturing required specialized machinery, skilled craftsmen, and significant time. The Sten required none of these. It could be produced in bicycle repair shops, toy factories, metal workshops. The first production Stens were manufactured by Singer Manufacturing Company in Scotland, the same company that made sewing machines. Later production expanded to Lines Brothers, a firm that made toys. The quality of these factory-made Stens was often superior to the rushed early models produced under invasion threat. The mathematics of mass production were revolutionary. A method pioneered by Walter W. Hackett of Ackles and Pollock changed everything. Hackett was joint managing director of a tube-making firm in Birmingham. The War Ministry asked how Sten barrels could be produced more efficiently. Hackett pioneered cold hammer-forged barrels using hardened steel mandrels. This eliminated the need for expensive boring and rifling machines. Using Hackett's process, 1 Sten barrel could be made every 10 seconds. 10 seconds. Sir Claude Gibb, who oversaw British weapons manufacturing during the war, said Hackett made the greatest contribution to the production of small arms during the whole of the war. The result was astonishing. Between 1941 and 1945, approximately 4.5 million Sten guns were manufactured in various versions. Only the Soviet PPSH-41 was produced in greater numbers during World War II. But production numbers tell only part of the story. The Sten's reputation among British troops was complicated. Early recipients were less than encouraging in their assessments. One Home Guard officer remarked that the weapons were said to cost 30 shillings each, and he did not doubt it. It is inaccurate over 50 yards and apt to be dangerous in the hands of an untrained man. The crude industrial appearance shocked soldiers accustomed to the polished wood and high-grade steel of the Lee Enfield rifle. Soldiers gave the weapon derogatory nicknames. The plumber's nightmare, the Woolworth special, the stench gun, a bloated piece of pipe, a wicked piece of vicious tin. The complaints were not merely aesthetic. The Sten had genuine reliability problems, particularly in early production. The Mark II and Mark III were temperamental. They could accidentally discharge if dropped or even laid on the ground while cocked. Some would fire full automatic when set to single shot. Others would fire single shots when set to automatic. This was particularly true of early Stens using bronze bolts, where the sear projection underneath the bolt could wear down more easily than case-hardened steel versions. The double-stacked to single-feed magazine configuration, copied from the German MP40, was prone to jamming. Soldiers quickly learned to load only 28 to 30 rounds in the 32-round magazine to reduce feed problems. But jamming remained a persistent issue. The first major combat test came with disaster. August 19, 1942. The Dieppe Raid. Operation Rudder. Canadian forces launched an amphibious assault on the German-occupied port of Dieppe in France. Many soldiers were issued brand-new Sten guns for the operation. The weapons arrived clogged with packing grease. In the chaos of combat, there was no time to properly clean and prepare the weapons. Stens jammed. Soldiers died. The raid was a catastrophe. 60% of Allied soldiers at Dieppe were killed, wounded, or captured. The Stens' reputation suffered severely. Yet soldiers who understood the weapon's limitations learned to make it work. British paratrooper Alan Lee said the weapon was best used for close-quarters combat. In a section of 10 men in the Paris, the sergeant and corporal always carried a Sten gun, as did most of the officers. When you went into a village or went into a house, whatever it was a reliable weapon. It was not a reliable instrument for anything over 100 yards, but for anything close quarters, it was very reliable. The key was understanding what the weapon was and was not designed to do. It was not a rifle. It was not designed for long-range accuracy. It was designed to deliver massive firepower in confined spaces. One Canadian soldier wrote a poem that captured the relationship soldiers developed with the Sten. "You wicked piece of vicious tin. Call you a gun? Don't make me grin. You're just a bloated piece of pipe. You couldn't hit a hunk of tripe. But when you're with me in the night, I'll tell you, pal, you're just all right." This was the Sten's truth. Ugly, crude, unreliable in careless hands. But in the darkness, in close combat, when everything depended on firepower and nothing else mattered, the Sten delivered. The weapon found its true purpose not on conventional battlefields, but in the shadows of occupied Europe. July 1940. Winston Churchill established the Special Operations Executive. The directive was simple: set Europe ablaze. SOE's mission was to damage the Axis war effort by creating and sustaining resistance groups throughout occupied territory. This required weapons. Lots of weapons. Weapons that could be easily transported, quickly concealed, and simply maintained by untrained civilians. The Sten was perfect for this role. The compact size of the Sten made it ideal for clandestine operations. The Mark II could be broken down into component parts in seconds. The detachable barrel, the removable stock, the rotating magazine housing. All of these features allowed the weapon to be disassembled and hidden anywhere. Under floorboards, inside false walls, buried in gardens. A complete Sten could be hidden in a space smaller than a briefcase. For resistance fighters operating under constant threat of German searches, this concealability was invaluable. SOE began dropping Sten guns across occupied Europe. The weapons were packed in specially designed containers and parachuted to resistance groups during nighttime flights. From 1942 onwards, the flow of weapons increased dramatically. By 1944 and 1945, Allied aircraft delivered over 20,000 containers and 11,000 packages of vital supplies to resistance forces in Western and Northwestern Europe alone. The containers included batteries, radios, explosives, and thousands of Sten guns. The weapon became the symbol of underground resistance. The French resistance received Stens by the thousands. Danish resistance fighters manufactured their own copies in bicycle repair shops and construction company workshops. Bopa produced around 200 in a shop south of Copenhagen. Holger Dansk produced about 150 in workshops throughout the city. Norwegian partisans used Stens against German occupation forces. Polish resistance groups received over 11,000 Sten Mark IIs from SOE between 1942 and 1944. But supply never met demand. The Poles began manufacturing their own versions in at least 23 underground workshops. Some produced straight copies of the Mark II. Others developed their own designs like the Polski Sten and the Błyskawica. The simplicity of the Sten made this indigenous production possible. Traditional firearms required specialized machinery and skilled craftsmen. The Sten required basic metalworking tools and determination. Barrels were the main challenge. Polish resistance fighters solved this by boring and re-rifling old rifle barrels. Parts were manufactured in small shops across occupied territory, then assembled in secret locations. Some underground Stens were marked in English to disguise their origin. The quality varied wildly. Some were as good as factory-made British weapons. Others barely functioned. But they gave resistance fighters the ability to fight back. The weapon armed 400,000 members of the Forces Françaises de l'Intérieur by 1944. Nearly a quarter of members in some units were equipped solely with the plumber's nightmare. Italian partisans used Stens to harass German forces throughout 1944 and early 1945. Greek resistance forces carried them. Albanian fighters received them from SLE agents. Belgian underground groups manufactured their own versions. The Sten appeared everywhere the Allies supported resistance movements. A suppressed version of the Sten transformed special operations warfare. The Mark IIS was one of the first submachine guns ever produced with an integral suppressor. SOE requested the weapon for clandestine missions requiring stealth. The Royal Small Arms Factory incorporated a specially designed suppressor into the Mark II. The barrel was ported and surrounded by a jacket filled with baffles to expand and dissipate propellant gases. The suppressor reduced the weapon's noise signature dramatically. Not silent, but quiet enough for close-range assassinations and ambushes. The first operational Mark IIS weapons saw combat in Europe in 1943 in the hands of SOE agents. They were used in the Far East by Force 136 and other clandestine units. Australian SAS used both the Mark IIS and the later Mark VI suppressed variant in Vietnam in the 1960s. American Military Assistance Command Vietnam's Special Operations Group units favored suppressed Stens for long-range reconnaissance, prisoner snatches, and assassinations. Operators liked the Mark IIS because it could be easily disassembled and compactly stored in a rucksack. British Special Forces continued using suppressed Stens until the 1980s when they were finally replaced by suppressed MP5 submachine guns. The most famous failure of the Sten came on that spring morning in Prague. May 27, 1942. Josef Gabčík and Jan Kubis were Czechoslovak soldiers trained by SOE for Operation Anthropoid. Their mission was to assassinate Reinhard Heydrich, the SS Obergruppenführer, who orchestrated the final solution and ruled Czechoslovakia with brutal efficiency. Heydrich was known as the Butcher of Prague. He systematically wiped out Czech culture and resistance in an effort to Germanize the nation. The Czechoslovak government in exile ordered his death. Gabčík and Kubis waited at a tram stop on Krčmerová Street near Bulovka Hospital. Heydrich's daily route was known. He traveled without armed escort in an open-top Mercedes-Benz touring car. This arrogance would be his undoing, but not in the way planned. At approximately 10:30 in the morning, Heydrich's Mercedes rounded the corner. Gabčík stepped into the street. He raised his Sten gun. Point-blank range. Impossible to miss. He pulled the trigger. The bolt locked. The magazine had jammed. Perhaps it was improperly loaded. Perhaps the spring was damaged. Perhaps dirt had fouled the feed mechanism. The reason did not matter. The weapon failed to fire. Heydrich stood in the car. His driver hit the brakes. Gabčík desperately tried to clear the jam. Kubis reacted instantly. He pulled a modified anti-tank grenade from his briefcase and threw it at the Mercedes. The grenade detonated against the rear wheel. Shrapnel and fragments of leather upholstery tore into Heydrich's torso. The Nazi officer survived the initial blast. He drew his pistol and attempted to pursue Gabčík before collapsing. Heydrich died 8 days later from blood poisoning caused by fragments of horsehair from the car's upholstery that entered his wounds. The mission succeeded despite the Sten's failure. But the weapon's unreliability became legend. Yet the Sten's overall impact far exceeded its individual failures. In trained hands, with proper maintenance, the weapon was effective. Historian John Warwicker claimed that exaggerated reports about the unreliability of the Sten were usually related to quality of manufacture. Don Hanscom and his comrades in the Thundersleep Patrol of the auxiliary units rated them more reliable than the Thompson submachine gun. Sten guns manufactured from late 1942 onwards were highly effective weapons. The early production chaos had settled. Manufacturing standards improved. quality control became consistent. British paratroopers adopted the Sten with enthusiasm. The weapon was lightweight at 7 pounds empty, compact enough to jump with, powerful enough for close combat. When British airborne forces jumped into Normandy on D-Day, many carried Sten guns. Lord Lovat's 1st Special Service Brigade stormed Sword Beach accompanied by bagpipes and Sten guns. The weapon had completely replaced the Thompson in northwest Europe by the time of the Normandy landings in June 1944. Not because military planners preferred it aesthetically, but because 4 million Stens could be produced for the same cost as roughly 170,000 Thompsons. The Mark V represented the Sten's final evolution. Introduced in early 1944, it featured a wooden pistol grip, vertical wooden foregrip, and a wooden stock. The sights were taken from the No. 4 Lee Enfield rifle. A bayonet mount was added. The Mark V could accept a No. 4 Lee Enfield bayonet. This variant was far more comfortable to fire than the Mark II or Mark III. Approximately 530,000 Mark V Stens were produced from 1944 to 1945. British paratroopers used them extensively during Operation Market Garden in September 1944. The Mark V remained in British service until 1956 when it was replaced by the Sterling submachine gun. Even Germany, Britain's enemy, recognized the Sten's effectiveness. Late in the war, as Allied bombing devastated German industry and resources grew scarce, Germany sought a cheap submachine gun for the Volkssturm home defense forces. The answer was obvious. Copy the Sten. From late 1944, Germany produced the Gerät Potsdam, an almost identical copy of the Mark II. Approximately 28,000 were manufactured. A modified version called the MP 3008 was also produced, differing primarily in mounting the magazine below the weapon rather than on the side. Roughly 10,000 MP 3008 submachine guns were made in early 1945, just before the war ended. The Germans captured large stocks of original Stens throughout the war. These were designated with MP numbers. The Mark I was MP 748E. The Mark II was MP 749E. The Mark III was MP 750E. The suppressed Mark IIS was MP 751E. The E stood for English. English. Even captured examples were used by German forces. The post-war history of the Sten reveals its lasting impact. British troops continued using the weapon in Korea, Malaya, Kenya, Cyprus, and Suez through the late 1950s. Israel, facing an arms embargo during the 1948 Arab-Israeli War, manufactured Sten guns domestically. Both before and after the declaration of the State of Israel, the Yishuv and later the Israeli Defense Forces produced Stens in underground workshops and official factories. The weapon provided the fledgling nation with a domestically produced submachine gun until indigenous arms industries developed the Uzi. Ironically, irregular Arab forces also used captured British Stens against Israeli forces. Sten guns appeared in conflicts for decades after World War II. Indonesian forces manufactured copies during the Indonesian National Revolution from 1946 to 1948. Chinese nationalist and communist forces used Stens during the Chinese Civil War and Korean War. Some Chinese Stens were converted to fire Soviet 7.62 by 25 mm ammunition. Vietnamese forces copied the design during the First Indochina War. The Viet Cong made them during the Vietnam War. Tibetan forces used Stens. Finnish forces acquired them. Albanian, Argentine, Danish, French, Norwegian, Polish, Portuguese forces all used Stens. The weapon appeared in conflicts from Europe to Asia to Africa to South America. American Special Operations Forces used suppressed Stens in Vietnam for quiet ambushes and prisoner snatches. Al-Qaeda weapons caches in Iraq as late as 2010 contained Sten guns. The weapon's simplicity ensured its survival long after more sophisticated firearms became available. Any group with access to basic metalworking equipment could manufacture a functioning Sten. This made it the ultimate insurgent weapon. It could not be embargoed or sanctioned or controlled. The design was in the public domain. The parts were simple. The manufacturing was achievable. The Sten became what it was designed to be. A weapon that could be produced anywhere, by anyone, with minimal resources. The Canadian production of Stens tells another part of the story. During World War II, the Long Branch Arsenal in Ontario manufactured approximately 134,000 Sten Mark II submachine guns along with 1 million magazines. Canadian-made Stens were generally considered to have better fit and finish than British versions. Smoother edges, better tolerances, more consistent quality. This was partly because Canada was not under direct threat of invasion or suffering bombing campaigns. Production could proceed with greater attention to quality control. Canada also manufactured approximately 73,000 Sten Mark IIs to aid China in its war against Japan. The weapon became a global commodity. The production statistics reveal an industrial achievement rarely acknowledged. From 1941 to 1945, Britain produced approximately 4.5 million Sten guns in various versions using a fraction of the industrial capacity required to manufacture conventional firearms. This freed factories, skilled workers, and raw materials for other war production. The same industrial base that might have produced 500,000 conventional submachine guns instead produced 4 million Stens. The mathematics of war are brutal but clear. Mass production of adequate weapons beats limited production of perfect weapons. The Sten embodied this principle absolutely. The weapon's technical specifications reveal why it worked despite its crudeness. Overall length was 30 inches. Barrel length 7.7 inches. Weight 7.1 pounds empty, 9 pounds with a loaded magazine. Rate of fire 550 rounds per minute for most variants. The Mark V fired at 600 rounds per minute. Magazine capacity 32 rounds, though soldiers typically loaded 28 to 30. The 9mm Parabellum cartridge was deliberately chosen for commonality with German weapons. Resistance fighters could replenish ammunition from captured enemy stocks. The weapon used blowback operation. Fire from an open bolt. Fixed firing pin on the bolt face. Simple. Reliable. Impossible to misunderstand. The manufacturing process was revolutionary for its time. Traditional submachine guns required skilled gunsmiths and precision machinery. The Sten required neither. The receiver was made from a simple steel tube. The barrel jacket was stamped sheet metal. The stock was a metal strut. The magazine housing was stamped and welded. The trigger mechanism was basic. Only the barrel and bolt required machining operations. Everything else could be fabricated in workshops with basic metalworking tools. This democratization of firearms manufacturing had profound implications. It meant small nations, resistance groups, and irregular forces could produce effective weapons without access to major industrial facilities. The Sten also represented a philosophical shift in military procurement. For centuries, military weapons were prized for craftsmanship. Engraved stocks, polished metal, perfect fit and finish. The Sten rejected this entirely. It was proudly utilitarian. Function over form. Effectiveness over elegance. This was shocking to military traditionalists. A weapon that looked like plumbing parts challenged deeply held beliefs about military hardware. Yet the Sten proved that crude could be effective. That cheap could be reliable. That mass production could win wars. This lesson influenced post-war military procurement. The American M3 grease gun, introduced in 1943, followed similar design principles. Simple, cheap, effective. The philosophy that birthed the Sten influenced firearms design for decades. The human stories reveal the weapon's true character. One 1944 dispatch noted that a Canadian battalion commander in Normandy personally hunted down a German sniper, tracked him to a barn, and gunned the bastard down with his Sten. King George VI, as honorary colonel-in-chief of the Home Guard, carried a Sten. He understood the weapon's symbolism. Britain would fight with whatever weapons it could produce. British Prime Minister Winston Churchill visited the test facility at Shoeburyness in Essex on June 13, 1941, and personally test-fired the Mark II. He understood the strategic implications. Britain could arm its forces and resistance movements across Europe using domestically produced weapons at sustainable cost. The Sten gun armed not just British and Commonwealth forces, but the entire European resistance. It gave ordinary civilians the ability to fight back against occupation. A farmer in France could hide a disassembled Sten under his floorboards. A factory worker in Poland could assemble Sten parts in a basement workshop. A resistance fighter in Norway could parachute with a Sten and ammunition in a rucksack. The weapon democratized warfare in ways that professional militaries found uncomfortable. It proved that effective military force could be generated without massive industrial infrastructure, that irregular forces could challenge conventional armies, that occupation could be made unbearably costly through decentralized resistance. The Germans learned this lesson painfully. Every German soldier in occupied territory had to consider that any civilian might be armed with a Sten, that any building might conceal resistance fighters, that any ambush could erupt from nowhere. The Sten forced German forces to deploy large numbers of troops for occupation duties. These troops could not be used on the Eastern Front or in North Africa or Italy. The strategic impact was massive. SOE estimated that resistance forces armed with Stens and other weapons tied down dozens of German divisions that would otherwise have reinforced critical fronts. The June 1944 Allied invasion of France succeeded partly because French resistance forces, armed largely with Stens, conducted widespread sabotage that disrupted German communications and delayed reinforcements. The weapon's legacy extends beyond its wartime service. The Sten proved that modern firearms could be manufactured using simple tools and techniques. This knowledge spread globally. Every insurgency and irregular force that followed studied the Sten's design. It became the template for improvised weapons manufacturing. Resistance movements in dozens of conflicts copied or modified the basic Sten design. The weapon demonstrated that technological sophistication was not required for military effectiveness, that mass production could overwhelm precision engineering, that desperate circumstances could drive radical innovation. The British military establishment that initially rejected the Sten's crude appearance eventually embraced it, not because they learned to love its aesthetics, but because 4 million Stens armed British forces and resistance movements across Europe while costing a fraction of conventional weapons. The rejection turned to grudging respect. The respect turned to recognition. By war's end, the Sten was understood not as a desperate expedient, but as a revolutionary approach to military manufacturing. It proved that total war required total industrial mobilization using every resource available. That perfection was the enemy of production. That good enough in massive quantities beat perfect in small numbers. The Sten gun was not the best submachine gun of World War II. The Soviet PPSH-41 was more reliable. The American Thompson was better made. The German MP-40 was more refined. But the Sten was produced in greater numbers than any Allied submachine gun. It cost less than any comparable weapon. It could be manufactured in workshops without specialized equipment. It could be disassembled and hidden in minutes. It fired common ammunition available across Europe. It armed resistance movements that tied down dozens of German divisions. It gave hope to millions living under occupation. These factors made the Sten not just successful, but revolutionary. The story of the Sten is ultimately a story about crisis driving innovation, about necessity forcing the abandonment of traditional assumptions, about democratic nations mobilizing every resource for survival. Britain in 1940 faced potential defeat. The response was not defeatism, but desperate creativity. Engineers designed a weapon that looked like plumbing but functioned like a submachine gun. Factories that made sewing machines and toys retooled to make firearms. Resistance fighters in occupied territory manufactured copies in bicycle shops. This was total mobilization at every level of society. The Sten succeeded because it matched the requirements of its time perfectly. In conventional warfare, against opponents at medium range and open terrain, the Sten was inadequate. Its accuracy beyond 100 yards was poor. Its crude construction offended military sensibilities. But in the close-quarters combat of urban warfare, in the hands of resistance fighters ambushing German patrols, in the darkness of nighttime raids, the Sten delivered devastating firepower. It was designed for a specific type of warfare and excelled in that role. This focused design philosophy made it successful despite its limitations. Nearly 80 years after its introduction, the Sten remains a symbol of wartime innovation. Museums across the world display examples and collections. Military historians study its development as a case study in emergency procurement. Firearms enthusiasts debate its reliability. The weapon appears in films, documentaries, and video games set during World War II. Its distinctive silhouette, with the side-mounted magazine and skeletal stock, is instantly recognizable. The Sten has become an icon not despite its crudeness, but because of it. It represents ordinary people doing extraordinary things under impossible circumstances. The lesson of the Sten Gun extends far beyond firearms design. It is a lesson about innovation under pressure, about abandoning preconceptions when survival is at stake, about matching design to purpose rather than purpose to design. The British military establishment wanted a submachine gun that looked and felt like a proper military weapon. What they needed was a weapon that could be produced in millions and distributed globally. Shepard and Turpin gave them what they needed, not what they wanted. This required courage. To present a weapon that looked like scrap metal to military officers accustomed to polished walnut and blued steel demanded either confidence or desperation. Probably both. The Sten also reveals something profound about total war. Modern conflicts mobilize entire societies. Every factory becomes a potential arms manufacturer. Every workshop a potential munitions plant. Every citizen a potential soldier or resistance fighter. The boundaries between military and civilian, between front line and home front, between combatant and non-combatant, blur and dissolve. The Sten embodied this total mobilization. It was made by civilian factory workers, often women, in factories that previously made sewing machines or toys. It was used by soldiers and resistance fighters interchangeably. It was manufactured in occupied territory by civilians resisting occupation. The weapon transcended traditional military categories. The final mark of the Sten's success is visible in the weapons that replaced it. The British Sterling submachine gun, which entered service in 1953, was a refined evolution of the Sten concept. Better ergonomics, improved reliability, more conventional appearance. But it retained the Sten's basic operating system, its side-mounted magazine, its 9mm chambering, and its focus on manufacturability. The Sterling was a Sten that could be produced during peacetime, when manufacturing standards could return to normal and cost was less critical than reliability. The Israeli Uzi, introduced in 1950, showed similar influences. Compact, simple, cheap to produce, effective in close combat. The Sten's design philosophy influenced a generation of submachine guns. The numbers tell the story with brutal clarity. 4.5 million Stens produced. Approximately $130 per weapon in modern currency. Total cost roughly $585 million to arm British forces and resistance movements across Europe. Compare this to producing the same number of Thompson submachine guns at $2,300 each. That would have cost over $10 billion. Britain could not have afforded it. The war might have been lost. This is not hyperbole. Wars are won by logistics, production capacity, and industrial output as much as by battlefield tactics. The Sten gave Britain the ability to arm millions of soldiers and resistance fighters at sustainable cost. This capability was essential to victory. The crude submachine gun that British High Command initially rejected became the second most produced submachine gun of World War II. It armed 400,000 French resistance fighters. It equipped British paratroopers who jumped into Normandy. It was carried by commandos who raided German positions across Europe. It was dropped to partisan groups from Norway to Greece. It was copied by underground workshops in Poland, Denmark, France, Norway, and a dozen other occupied nations. It remained in service for decades after the war. It influenced post-war submachine gun design globally. It became a symbol of resistance against tyranny, and it cost $10 to make. This is the story of the Sten Gun, a weapon born of disaster at Dunkirk, designed in desperation during Britain's darkest hour, rejected by military traditionalists for its crude appearance, produced by the millions using revolutionary manufacturing techniques, distributed globally to regular forces and irregular fighters, unreliable in careless hands, but deadly effective in trained hands. Simple enough to manufacture in bicycle repair shops. Compact enough to hide under floorboards. Powerful enough to kill at close range. It looked like plumbing parts. It changed the war. It armed resistance movements that made occupation unbearable for German forces. It tied down divisions that Germany desperately needed elsewhere. It gave hope to millions living under Nazi rule. It proved that crude could be effective, that cheap could be reliable, that mass production could defeat precision engineering. It was the plumber's nightmare that became a symbol of freedom. On that spring morning in Prague, when Josef Gabčík's Sten jammed and failed to fire, it seemed to confirm every criticism of the weapon. Unreliable. temperamental, dangerous to its user. Yet Jan Kubis' grenade still killed Reinhard Heydrich. The mission succeeded despite the weapon's failure. This was also the story of the Sten. Not perfect, not elegant, not refined, but sufficient. And when millions of sufficient weapons can be produced and distributed globally, when ordinary citizens can manufacture effective firearms in basement workshops, when resistance becomes possible for anyone with basic metalworking tools and determination, then crude becomes revolutionary. Then cheap becomes strategic. Then plumbing parts become symbols of hope. The Sten Gun did not win the war alone, but it armed those who did. And that, ultimately, is what mattered. 80 years later, the Sten remains a reminder that innovation often comes from desperate circumstances. That traditional approaches fail when conditions are not traditional. That aesthetic elegance matters less than functional effectiveness. That democratic societies can mobilize every resource, adapt every factory, arm every citizen when survival requires it. The weapon that looked like scrap metal helped defeat Nazi Germany. The submachine gun that British officers called the plumber's nightmare armed the resistance that made occupation impossible. The $10 weapon that High Command rejected was built 4 million times and changed the war. This is the paradox of the Sten, rejected and embraced. Crude and effective, despised and essential. It was exactly what the moment required. Nothing more, nothing less. And that made it one of the most important weapons of World War II.